Hello and welcome back. In this video we'll discuss linear functions. There is a PDF available if you would like to follow along and print it out. A couple of definitions. What is a linear function? It's a function that's described by the form of f of x is equal to mx plus b. And we're telling you that x, m, and b are any real numbers, meaning they don't contain any complex or imaginary numbers. The graph of f, which is from this f of x, is the same thing as the graph of y equals mx plus b, which is a line, straight line with a slope of m and a y-intercept of b. A constant function is a linear function in which the slope is equal to 0. So if we put a 0 up here in place of m, it doesn't matter what we put in for x, we always get a 0 here, and the only output there is a b value. So you end up having a constant function, which is actually a horizontal line. Rate of change, that's really the same thing as slope. We call it the change in f of x. Remember, f of x is the output, so it's really the change in y over the change in x. Example 1, we want to find the rate of change for f of x is equal to 2x minus 4. Now, if you remember, m is really the slope, and another name for slope is rate of change. So this really is our rate of change right there. But how do we find the rate of change if we're looking at a table like this? Well, the first thing we got to do is find the common difference between all these numbers, and you'll see that that's a plus 2 all the way down. And then we're going to find a common difference between all of these numbers, and that's going to be a plus 1 all the way down. And since this is really the y side, the f of x side, the change in f of x over the change in x is going to be 2 over 1. Now, if it's truly the rate of change, we can take any of these two numbers, let's say negative 2 up to 4, well, that would be a change of 6, but then I'd have to start at 1 and go all the way up to 4, and that would be a change of 3, and you'll see we still end up with a rate of change of 2 over 1. Example 2, we want to write the equation or function when f of 4 equals 1 and f of 8 equals 7. Well, what that means is we have an input or an x value of 4 and an output of 1. And the same thing here, when we have an input of 8, the output is 7. Basically what they're telling us is we have 2 points there, x and y's. So first thing you need to calculate is the slope of this line, or the rate of change. So 7 minus 1 will give us 6, and then 8 minus 4 will give us 4, and I'm just going to reduce that to 3 over 2. So our constant rate of change, or our slope, is 3 over 2. Now remember, we can write these things when they're linear functions. It's really the same as y equals mx plus b, in which we have x, or f of x, representing y. So I still need to find the b value. So all I got to do is substitute m with what the m value is, which in this case is 3 over 2. Bring down my b value because I'm solving for b. And then pick one of those 2 points for x and y. I'm going to choose this point here, which is 4, 1. So I'm going to put the 4 here, and the 1 on this side, and 1 is going to equal 4 divided by 2, which is 2, times 3 gives me 6, plus b, and then subtract 6 from both sides, and you see the b value is equal to negative 5. So to write this in function form, or actually I'm going to write it in equation form first, so y equals 3 halves x minus 5, and if I want to put it in function form, all I could do is substitute y with f of x is equal to 3 halves x minus 5, and these two mean the same thing. Example 3a. At noon, a pump started emptying an oil storage tank at a constant rate. Now, when they tell us we're talking about a constant rate, what that means is it's implying that we're talking about a linear equation or a linear function. At 2 p.m. there were 1,680 barrels left in the tank, and at 5 p.m. there were 600 barrels left. First thing they want us to do is write a linear function to describe the situation. And people often look at this and go, well, there's no points. Well, there actually are points. We have a time value here, and we have a barrel value there. So we can actually define f of t to equal number of barrels since noon. And the only thing I got to find out first here is the constant rate of change, which is really my slope. So if I have a 2 and a 1680, that's my first point, and a 5 and a 600, and that comes from the time and the number of barrels left in there that was given here and here. Then I can just subtract 1680 minus 600, and that's going to give me 1080. And then I can subtract 2 minus 5, and that's going to give me a negative 3. So that's going to come out to negative 360, which is my M value. So since this is barrels over time, this is really representing 300, or losing 360 barrels per hour. The only thing I got to calculate now is my B value. So I'm missing my B value. So if you write the regular equation, which is y equals mx plus b, and substitute in place of m my negative 360, I can substitute an x and a y into this problem to calculate b. I'm going to choose the smaller of the two numbers, which is 5 and 600. The 5 is the x value, and the 600 is the y value. And now I just need to calculate my b. Negative 360 times 5 will give us a negative 1800 plus b, and it's still equal to 600. Then I'm going to add 1800 to both sides to get my b value, so my b value ends up being 2400. So to write my function, f of t is equal to negative 360t plus 2400 barrels. So the number of barrels left in the pump, or in this storage tank, is a function of time, in which it's losing 360 barrels per hour. Example 3b, same scenario, only now they want us to know how many barrels were in the tank at noon. Remember that f of t was described as the number of hours since noon. So at noon, no time has passed. Therefore, the time value would be equal to 0. So what they really want us to find is f of 0. F of 0 would be negative 360 times 0 plus 2400. So f of 0 will equal 0 plus 2400. So the final answer for f of 0, which would be noon, because 0 represents noon time, would give us 2400 barrels. So our 2400, which is our y-intercept, ends up being our starting amount. Example 3c, the same scenario, only now they're asking us what time will the tank be empty. So how long before the tank will be empty? Well, remember, f of t is our output, so we want our output to equal 0. So we want the tank to be empty. So we're going to just substitute a 0 in there, negative 360t plus 2400. And since this is really the y value, that's like calculating the x-intercept. So what they're really asking us is the x-intercept, which is the time it takes for the tank to be 0. So move the 2400 over, and you get negative 2400 is equal to negative 360t. Divide both sides by negative 360. And the time value ends up equaling 6.6666, which is 6 2/3 hours. Now the question isn't how long, but what time will the tank be empty? Yeah, it's going to take 6 2/3 hours, but it's going to take 6 2/3 hours since noon. Well, noon plus 6 2/3 hours gives you 6 o'clock, and then 2/3 of an hour would be 40 minutes, so it'd be 6:40 p.m. I've gone ahead and put this example on a graph here, and we've got time down at the bottom, and we've got barrels on the side, and up here is our starting amount, or how full the tank is when it was starting, and that was 2400 barrels. And as we go down, or as time progresses this way, the barrels is getting lower because we're losing 360 barrels per hour, and that represents a negative relationship. As expected, our slope was also negative. I just happened to plot one particular point right here, and if we look over here, here's what the calculator showed us, that was a 6 and a 24, or 240. Since our x axis is time. That's 6 hours, or after 6 hours, there's 240 barrels left in the tank. So it's going to take another 40 minutes to finish draining those 240 barrels.